Alright, let's start this video off with some review, I hope. Simplify this expression. What do I need to do here? Well, I see minus and plus, so I've got 1, 2, 3, 4 terms here, but they're trapped inside these parentheses with a 3 on the outside. So I think that means 3 multiplied by each of these 4 terms. First, do I have any like terms here? X to the 5th, x squared, plain x, constant term. No like terms to combine, so all I can do is distribute. Let's try again there. Okay, so the 3 times 18x to the 5th. 3 times 18 is 54, right? 30 plus 24, 54 times x to the 5th. Then 3 times 3 is 9. I guess I can write it. I can recognize this is 3. That's a negative 3, so it's going to be negative. And then 3 times 15. 3 times 15 is 45. So that's 45. And then positive times a negative is negative. And then 3 times 54. Alright, 3 times 5 is 15, so that's 150. Plus 3 times 4 is 12, so that's 162. Of course, if you want to do that off to the side, 3 times 4 is 12. 15 plus 1 is 16. 162, if you're not comfortable doing that in your head. So now I don't have parentheses anymore. I still don't have like terms. If I didn't before, I'm not going to now. And highest degree 5, 2, 1, 0. This is in standard form. I'm done. So put a box there. Pretty straightforward. Right. Let's try another one. How is this problem different from the one we just had? Structurally, it's no different. Right? I still have some number that I'm distributing by each term in here. So I have 1/3 times 18 x to the 5th. 1/3 of 18 is 6. 1/3 times 3. 1/3 of 3 is 1. I'm not going to write 1x squared. I'm going to simplify that to just plain x squared. If I had written 1, that's not wrong, but that means I'm definitely going to need to write an extra line here below where I've simplified that. So to save myself the time, I just leave that one off and leave it as plain x squared. Then 1/3 times 15. 15 divided by 3 is 5, so I'm good. And then 1/3 times 54. 1/3 of 54 is 18. And if you're not sure about that one, if you don't have that memorized, one way is to do the long division. 5 goes into 3 once. 3 goes into 24 8 times. There's our 18. Right? If you recall just a moment ago, we said 3 times 18 is 54. So now we're saying 1/3 of 54, that's getting us back to 18. Another way to deal with that is to factor 54. If I have 54 over 3. 54 I recognize as 6 times 9. And then I could either say 6 divided by 3 is 2. 2 times 9 is 18. Or I could say 9 divided by 3 is 3. 3 times 6 is 18. Or actually work that out all the way. It's a little bit of overkill. And there's my 9 times 2 or 6 times 3. However works best for you to be able to simplify that expression, we each have our own preferred methods. And again, no like terms. It's in descending order of the exponents, so it's in standard form. So I'm all set. Now I want us to remember how we did this problem, because it's going to be written in a slightly different way in just a moment, even though it's representing the same thing. Before we get to that, let's try just a couple more here. Same deal. So 1/6 times 18x to the 5th, 1/6 times 3x squared, 1/6 times 15x, and 1/6 times 54. Now, a sixth of 18, that's not so bad, right? 18 divided by 6 is 3. But now 3 divided by 6, that's not coming out as a whole number. It's often easier to deal with these expressions when we write this not as a multiplication problem, but as a division problem. If I write this, let's pick the right color here, as 18x to the 5th divided by 6. And then 18 divided by 6 is 3. 3x squared divided by 6. 15x divided by 6. 54 divided by 6. And here a 3 cancels. 6 is 3 times 2. But I don't have something times x squared like I had up here, where the 3's canceled, or where I was actually multiplying. Right? Here the 2 is left in the denominator. Here 15, that's 5 times 3. 6, that's 2 times 3. So the 3's cancel. I'm left with a 5 up top and a 2 on the bottom. Right? And then 54, we just looked at that, right? 54 is 9 times 6. So I can cancel the 6's completely, plus 9. So that is one way to answer this question, with some big fractions there. However, we really like our standard form where we have a coefficient times x raised to some power. And this expression doesn't quite fit that format, where it's not something times x squared. Now I have x squared being divided by something. So we can actually rewrite this as 3x to the 5th. That's just fine. This is where our work with unit fractions can be so helpful here, right? I recognize that dividing by 6 is exactly the same as times 1/6. Well, dividing by 2 is the same as multiplying by 1/2. Same thing here. X is being multiplied by 5 and divided by 2. Well, divided by 2, that means times a half. So times a half and times 5, that's the same as times 5 halves. Right? I'm just taking that denominator and sliding out front as the denominator of the coefficient. And that is much more preferred when it's possible. Right? I believe your online system will accept either of these as simplified answers, but this is the one usually preferred. All right. One more problem here. What's more complicating here? Right, we have an x in the denominator. So I'll go ahead and distribute. And I'm just, because that's just a 1 over top, I'm going to distribute this as the denominator. All right. And maybe it'll be nice to show the factoring here to simplify that. So 18 is 2 times 9. 2 times 9 times 5x's over, oh, come on now. There you go, over 9x. So the 9's cancel. A single x cancels, so I'm left with a 2x to the 4th, right? 1 less than 5 is 4x's here. 3x squared, since that's just x squared, I'm going to write that out. That doesn't take so much space. 9x, I can factor 9. It's 3 times 3. Now, why did I factor 9 here, but I didn't bother to factor it here? Because I didn't need to factor the 9 here, right? 9 was canceling with 9. I don't care that it's 3 times 3 and 3 times 3. I already know that it's the same number. Over here, I don't have a 9 in my numerator, but I do have a 3. So I can cancel those two 3's, cancel those two x's. I'm left with x over 3. Here, 15, that's 3 times 5. 9, 3 times 3. 3's cancel, and x's cancel. Now, I should have a disclaimer here that x is not equal to 0. Right? I don't know the value of x, but if x is 0, 0 times 9 is 0. I'm dividing all of these things by 0. No, even 0 over 0 is undefined. Right? 0 over 0 does not equal 1. It is true that 0 equals 1 times 0. 1 times 0 is 0. But 0 also equals 7 times 0. So if I divide both sides by 0, I'm not getting 1 necessarily. I could get any real number here. So even when I'm canceling x with x, 0 divided by 0 doesn't cancel, it doesn't work. But so long as x is any number, any real number besides 0, I can cancel x with x. That cancels out exactly the same way 3 cancels with 3. I'm left with 5/3. Here. Right? And then my last term, 54 is 6 times 9. 9's cancel. I'm left with 6 over x. Now this is not a polynomial. Right? Even if I wrote this as 1/3 x and 5/3, you could have a fraction for your constant term. That's no big deal. 4th degree, 1st degree, 1/3 x, 0th degree constant term, -1th degree. Even if I write this without denominators per se, let's switch colors here. 2x to, oh, why is it so fat? 2x to the 4th minus 1/3 x minus 5/3 plus 6x to the -1. Right? That fits our formatting a little bit better. I don't have x as a denominator, but x, it really is still a denominator. Right? Polynomials cannot have negative exponents. So we have simplified in a sense, but we've recognized that this 4-term expression is not a polynomial. So because negative exponents are not generally considered simplified, we'll leave it like this. But we actually have another option. Right? Here's my polynomial divided by 9x. I could just write that as my polynomial divided by 9x. This expression is identical to this expression. I could have done the same thing over here. Instead of times 1/6, I could have written my 18x to the 5th minus 3x squared minus 15x plus 54 all over 6. And the process is identical. I'm taking this, dividing it by 6. That's what I did. Taking this next term, dividing it by 6. Taking this next term, dividing it by 6. Taking this last term, dividing it by 6. And each of my terms is having this 1/6 distributed to it. Right? That's what is going on here. Even when we start with it in fraction form, what do? We take this first term, divide it by 9x. Take this second term, divide it by 9x. Take this third term, divide it by 9x. Take this fourth term, divide it by 9x. And then we go on from there. Now this is how we're going to see things most commonly, and that's what we do. Now there is some middle ground here. If we see an expression like this with the directions to simplify, this might not necessarily be what we want. So to see what we might actually want, we have to look at a couple more problems. First, this problem. Now, we can see what this would have looked like in the fraction form. But if we try to take this expression and simplify it the way we've been doing, this first term times my coefficient here, right? Distribute all of this. Right? This first term divided by 9x plus 2. Next term divided by 9x plus 2. Last term. Doesn't really work here, right? 18 is 9 times 2. But my denominator has a sum. Right? I can't cancel a 9 because this isn't something times 9. It's something times 9 then plus 2. Let's pick a number for x. Let's say x is 2. 9 times 2 is 18. 18 plus 2 is 20. Can I cancel a 9 from 20? No. Pick 10. 90 plus 2, 92. Can I cancel a 9 from 92? No. Nothing cancels here. It's not going to work out. We can't even cancel the 2 because it can't be guaranteed that this is an even number. If x is 1, 9 plus 2 is 11. No, 2 doesn't cancel with 11. Right? I can't cancel in this instance because I don't have a factor in the numerator and denominator that's the same. Once we have more than one term in our denominator, we can't simplify these expressions the same way. Right? Now we will look at how to simplify these expressions in our next video, but for now we need to see all of these techniques only work when we have a monomial, a single term, as our denominator.